Hi there once again, and welcome to another Expresso Mechanic tutorial. And in this one, it's going to be a Python tutorial, and we're going to be building a rig to automatically switch camera positions based upon the proximity of an object to any given camera. So what's happening here, you can see that we've got 4 cameras. We've got 1, 2, 3 and 4. And as the orange cone object gets within a certain distance from each camera, then basically we switch the view. And at all other times when the cone is not within range of a given camera, then we're switching to a camera that shows the overall scene. That's what's going to be happening here. That's what we're about in this tutorial. So without further ado, let's see if we can make this happen. Before we really get into this, I just want to give a shout out to Rob Mack for coming up with the idea for this particular tutorial. Let's get a hold of a circle. We'll put it in the XZ plane, make its radius 2000. Hit H so that we can see the whole scene. Hit C to make this editable. We're in points mode. Select one point, select all, so Command A to select all. Hold down the Control key and we'll subdivide. Fantastic. So what we can do next is select every other point. So we'll select the points on the poles of the compass, as it were, and then we'll use our scale tool, and we don't want to scale in the Y, so we'll just lock that. And then we can think about scaling our circles. Just hold shift and get that point there. Okay, brilliant. So let's just do a scale. Bring this out. It doesn't really matter how big this is. Somewhere like that, I should think, will be fine. Something like that. Okay, great. So that's our path, and we're going to put a cone object on this path. So let's just do that next. We'll grab a cone in, and we can leave it pretty much at the size it is. I mean, if we wish to, we can make it a little bit bigger, but we'll leave it at that size. I think it doesn't really, no real need to change it. Make it +Z in the orientation, because we're going to be using an aligned spline, and that's a good orientation to have it in. So let's get an animation tag aligned spline. We'll get one of those on the object. Click tangential, because that's what we'll want, and we will want it in the Z. Drag the cone in, not the cone, the circle, I beg your pardon. Drag that in as the spline path, and we can see that we've got that there. Now the one thing I will do with the circle, I will actually go into my spline here and into my point order, and I'm going to move down sequence so that we start here. Okay, brilliant. So we've got it that far. Let's just colour the actual cone. We'll make it orange, as I did in my example. Great, so that's ready, and it will do what we need it to do. So we can just move that, and we're going to go all the way around the spline path. Fantastic. So we've got things that far, and now we can think about moving on to our next step. I'll bring in a text spline and place a number 1 in the field. Now the font I'm going to change. I'm also going to change the height, make that 800. Its alignment I will make middle, and the font I'm going to change to Lemon Milk Pro. You can use any font you choose, but I'm going to use this one. I just happen to like that font, and its plain I will make ZY for the number 1. Okay, I'll Command drag to copy, place a number 2 in the field, and on this occasion I'll adjust the coordinates down here. I'll work with the rotation and set that to 90 degrees. If I can just get it right, let's go select this, coordinates, go in here, 90 degrees. That's better. Okay, so that's 90 degrees to its left. Command drag to copy once again, and in the object text spline we will make this a number 3, and on this occasion in its coordinates make this 180. Repeat the process once again and give ourselves a number 4 in the text spline, and then in the coordinates 270. And that's everything set up the way it needs to be so far. So the actual rotations of all our splines are now correct. We just need to position them. So with our number 1 selected, we'll make this 400 along the x-axis. The number 2, 400 along the z-axis. The 3 needs to be minus 400 in the x. And finally the 4 minus 400 in the z. Great, so all of our text splines are now set up to give us our camera angles. That tells us where our cameras are going to be looking, because our cameras are going to be placed on the apexes of these particular curves. Right, so that's got that far. We need to select all of our splines, hold down the Option key and place them into extrudes. All good. The Object tab here, everything is set up fine. We don't need to change that. The caps we'll just give a size of 10 for the rounding, so for our beveled edge, and the segments I'll just make 5 because they're quite large objects, and that's all I'm going to do there. So we've got our numbers. I'm just going to call this 1, 2, 3 and 4 so that we know what they are. Fantastic. And now we just need to colour them. So our number 1 we will make red. Something like that will do fine. The 2 blue. Somewhere there I think we'll do okay for that. The 3 will be a yellow. Something like that. And finally the 4 will be green. And that gets everything coloured. So there we are. We've got our camera angles labelled. The next thing we can do is actually bring in a scene object, or rather a stage object, I beg your pardon, that's what I should say. So let's see if we can find one of those. Bring in a stage object. And this is of course what we're going to be using for each of our cameras. We're going to be passing a camera into here. We'll worry about that in a little while. Moving on from here, we'll bring in the actual cameras themselves. So we can bring in our first camera, and these don't actually have to be camera objects. You can use nulls, but for the sake of clarity here, I will use cameras. So I'm going to bring a camera in here. So this is our overall scene camera. We've got that in. We'll just hide that. And the next thing we need to do is start worrying about positioning our cameras for each of our angles at the apexes of these curves. Let's bring in another camera, and on this occasion we'll select its coordinates and zero it out. And zero the rotations out too. We'll make this camera 1, so this will be facing towards our number 1, and we'll bring this over here. Let's bring it to somewhere around 5,150. I think will be okay for that. We'll zoom out a little bit further. Just zoom out, and we can rotate this 90 degrees. I'll just hit F2 to get into my top view, and we can see that that's going to be good, I think. Let's just go back to our 3D view, so F1, and switch to that camera. And we can see that we're taking in the cone and everything else. Now it's not quite set right, so what we need to do is just move this camera up. If I go into my right hand view, I can see where my camera is. Now if we just move over a little way, we just want to frame everything, so we want it somewhere around there. I think will be okay. Let's have a quick look. We go back to our 3D view and we can see through our camera. I would say that's pretty good. That's quite a nice framing for that, and I think that will work out okay for us. So we'll go back to our flying camera and carry on from here. So our camera 1 is in position. If we command drag to copy and we move our camera number 2, and that's what this will be, and it's labeled camera.2. So this will be camera 2. If we make this 5,150 in the Z and zero it out in the X, and then we can rotate it by 180 and take a look through this camera, and we can see that that's framing okay. So that's all good. Back to our flying camera. Once again, we can simply command drag to copy this, zero it out in the Z, make it minus 5150 in the X, and then rotate it 270 degrees. And now that one is in the correct position, and then all we've got to do is copy once again. In fact, what we can do, we could copy camera 2, drag it down to the bottom there, and all we've got to do is set this up at minus 5150 along its Z-axis, and then rotate it 360, and that will be perfect. If we select our frame, we can see that it's fine. So that's our cameras in. This camera here we'll name camera.5, and then what I'm going to do is hide all of my cameras, because we don't really need to see them. We can see the framings are good. Select them all, hold down my option key and hit G to group them. Rename the null camera, and we've got everything sorted out there, and they're all good. Let's just go back to our camera 5. That's fine. Our stage object is ready to receive cameras here. So the next thing that we need to do is bring in a null, call it Expresso, give it an Expresso tag. We've got the editor open and we're ready to start work. Very, very simple. We just need to bring the stage object in, and we need to give it at the input stage object properties camera. That's as much as we need to do with that, and then we can simply bring in a Python node. So come down to script, Python, and remove both the inputs because we don't need those at all. And at the output stage we can remove this one, and we can add a link. That's what we're interested in. Now we'll connect these two together and we'll get a yellow top on the Python node, because at the moment we've got no value for this output, and we're going to rename the output cam. So that's what we'll rename that, and that's ready to go, and we're not worried about this yellow top at the moment. We'll sort that out. Okay, fine. So we've got everything to that stage and we're ready to start coding. We'll switch to a scripting layout, select the Python node once again and open in Python editor. And now we're ready. The first thing we can do is remove line 10. We don't need that. And up here we can say global cam comma, and it will be index, because we will be needing an index list. The next thing we need is the ubiquitous frame variable. You've seen me do this many times if you're familiar with my tutorials, but if you're not, what we're doing is getting the current frame from the timeline. And we can say doc.get frame, open close, .get, I beg your pardon, that should be get time. I should know that, I've done it so many times. Get time, open close, .get frame. Open doc.get capital F PS open double close, and that's our frame variable taken care of. Moving on from here, we can say if frame is equal to 0, so at the start of the animation we want to do something, and that something is to define what's going on with our index, and we can simply say index is equal to an empty list. And that's as much as we need to do at frame 0. That's the only variable that we need to define. The next thing we need to do is bring some objects in from the object list. We need camera and we need cone. So we can say camera is equal to, and it will be doc.search object, open brackets, open single quotes, camera, close single quotes. So that's going to grab this object and bring it into our code. The next thing to do, as I say, we need the cone. So if we copy this and we just paste it in here, change camera to cone and camera to cone, and that will bring our cone in from here. Don't worry about this. As I said, it's because we've got no value at the cam output port. That's all the errors are coming in for. So just ignore those for the moment. The next thing to do, we actually need to bring these child objects into the scene from our camera. So we can say cameras is equal to, and it will be camera dot get children, open close, and that will bring this list of objects in. And to prove it, we can print them. So if we say print open cameras, we should find that we get them, and we do. We still get the error, but that doesn't matter. We can see that we've got these objects here, and it says we've got an object called camera 1, 2, 3, 4 and 5. So we're bringing these objects in, and that's doing exactly what we want. Now, if we want to get rid of this particular error, because we've got nothing at the cam port, what we can do, we can simply say cam is equal to cameras brackets 4, and that will give us camera 5, because obviously camera 1 is actually 0 to it go in index value terms 0, 1, 2, 3 and 4. So camera 4 is going to be the camera that we're currently looking through. Okay, so if we just clear this out now and execute, we no longer get that error because we are now passing a camera there. And if we open the Expresso, we can now see that the yellow top has gone. Okay, so that's fantastic. We've got that far. The next thing we need to do is sequence through these cameras. Okay, so we need a for loop. So for I in range, and it will be len in brackets, open brackets again, and it will be cameras, double close, colon. So what are we actually going to do? Well, we're going to actually be working out the distances between the cone and all of these cameras. The flying camera will also be included, but we're not as bothered about that as we are these four, because these are the really important ones. But the flying camera, it is important because we are going to be using it at different times. But these four cameras are of great importance to us. Okay, so let's start work on this. So we can say cone underscore pos is equal to, and it will be cone dot get ABS for absolute pos, open close. So we want basically its global position. I mean, we're getting its position relative to the center of the Earth, or the Earth, center of the scene. But anyway, that's what we're getting there. The next thing we need to do is get a camera's, all of these cameras' positions, basically, including the flying camera. So we can say cameras underscore pos is equal to, and it will be cameras, and again it will simply be this, so we can copy this and paste it in there. Also though, we need to add here open brackets I, because obviously we want all of the cameras. We're going to sequence through all of the cameras, and we need to get the positions of them all. The next thing we need to create is a difference vector. So diff vect is equal to, and that will be cone underscore pos minus cameras underscore pos. So we'll get the position of our cone, the position of our cameras in sequence, and we will subtract one from the other to get the difference vectors between them. Now the last part of this is to get a distance vector. So it will be dist underscore vect is equal to, and it will be diff vect dot get length. So we're going to measure the length of our distance, or of our difference, I beg your pardon, vectors. Okay, and that's what we're doing there, and that will tell us how far away our cone is from our current camera, well, whichever one we're having to be looking at as we sequence through this for loop. So that's great, we've got it that far. Now we can then say if, and we've got to check to see whether or not our camera is within a certain distance from our cone. If our cone is close enough to our current camera, then we want to switch to actually viewing the cone through that camera. So in order to do that, we've got to actually ascertain how long our difference vectors and our distance vectors actually are. So what we'll say is print for now, actually, and it will be underscore dist underscore vect. Okay, so we'll print those out and see what we get. Let's just execute that, and we get 5 vectors. Now at the moment we can see that we're quite close to our first, which is going to be, this will basically be 0 because I will be 0 when it's grabbing a hold of this camera's position. So our first camera we're quite close to, and we're close to our camera here too. But what we need to do is basically ascertain when we're close to this camera first. That's going to be the camera that we're going to be most interested in first. And you've got to remember that this cone is going to be moving around. That's something that we also need to set up actually. But don't worry about that for now. We'll get to it later. Okay, so we've got our dist vectors and we're looking at those. Now, moving on from here, we can then say, and let's just see where we are. Okay, we'll get within a certain range. I mean, what we'll do, in actual fact, let's just print that again, and we'll work out how we're going to do this. So if we print dist vect, just clear that out. We've got them there. Let's just go into here, and if we just step through until we get it within range, and I think if we just bring camera 1 in for now, I mean, we're going to be in range. If we just select this, if we can. Oh, we said we wanted that, didn't we? Let's just place camera 0 in there and execute that, and that's switched that for us. Yeah, I mean, I think if we're about here, that's probably about where we can start thinking about switching cameras. So let's just see what we've got there. So 3,574. Okay, that's the length of that vector. So we could say if dist vect is less than or equal to, and we'll say for the sake of argument 3,575, just to give us a round number, then we're going to do something. And what we'll do is actually get an index value into here. That's what we're going to do, and you'll see why. We can then say if len index is less than 1, because we only want a single value to be stored in here. So once we've got a value in there, we don't want any more. So if the length of index is less than 1, we can then say index dot append, and it will be I, because the initial index value that we're going to want will be 0, because we'll want camera 1, and of course camera 1 will correspond to 0 in our cameras list. So that will be the index value of camera 1. So we'll get the first of our distance vectors. That's what we're going to do. So we've got an index value of 0 initially being grabbed in. Fantastic. So we can move on from here and do the next part. What we'll do, we can just switch that back to camera 4 actually, just execute that. That's fine. So let's just carry on. We can then say at this level, if, so at the same level as our 4 here, if len, and it will be brackets index, is equal to 1. So once we've done this part and we've got something in there, then we can start doing something else. We can then say current cam pos is equal to cameras, and it will be open brackets index open brackets 0 double close dot get abs pos. So now, while up here we were looking at 5 distance vectors, we've now isolated the one that we're interested in, and we're going to be we're basically going to be doing the same thing we did up here, but only with one of these distance vectors, the one that we're interested in. So the one for this particular camera on this occasion. Okay, so that's why you must do this, because if you don't, you're never going to know which camera you're supposed to be looking through, because you're constantly going to be looking at all these distance vectors. We just want to look at one at a time, and that's what this piece of code is for, this one that we're working on now. So the next thing, cone pos. Well, what we can say here, in actual fact, we can just copy this line because it's exactly the same. Just copy this line and we'll put this in here. So cone pos is equal to cone.getAbsolutePosition. That's fine. Moving on from here, we need a difference vector. So diff vect is equal to, and it will be cone underscore pos minus, and this time it will be current cam pos. So we can copy that and place that in there. The next thing again is this here. We want a similar thing here, so we'll just type this in this time. Dist vect is equal to, and it will be diff underscore vect dot get length. That's fine, and that's ready to go. Now, once again, we can say this line here, same thing, copy this, paste it in here, but this time I'm not going to make it the same value. I'm going to let it get a little bit closer to the camera before I switch it. So we've used this to actually get the distance vector that we're interested in, and at this point we're going to measure that vector again, allow this cone to get a little bit closer, and then we're going to switch the camera. So I'm going to just say, let's have a look. So if I say 3,450, so that it's a little bit closer. So we've got that bit sorted out. We can then say cam is equal to, and it will be cameras open brackets index open brackets 0 double close. So we're interested in looking through the camera that corresponds to this index value. And then it will be a case of saying else index dot clear. So if we're out of this range, we want to actually clear the index, because we want to set up to grab the next index value. So every time we're out of range, we know that we've got to get the next index value. So we must clear our index list. Fantastic. And then we also know that at all other times we're going to be wanting to look through this particular camera. So all we need to do is say else and then tab this in. And that's it. We've got our code. Now, if all things are being fair and I've done this correctly, it should work. But we'll see if it actually does. And straight away it's saying that it can't find a value for cam in Python. Let's just make sure that we get what we want. It's still saying the same thing. Now that could be because I've got a typo in there, or it could be something else. Let's just double check what we've got there. So we're still getting that there. Let's just see what happens when we run. I don't think anything's going to. No, we've still got that problem. Okay, so I need to run some checks and make sure that everything is okay. Now, when I did this originally, I got a similar problem, and it was just a really weird ghost in the machine type thing. But we'll see if it's that. I'm just going to double check the code, and then I'm going to come back and carry on and see if I've got any problems. Okay, I think I know what the problem is actually. What it is, we didn't set this up yet. So we've got this, we've got to make sure that we set this up correctly. And we can see that it's starting to work. If I just move through, it is starting to go. Now let's just work this out. So if we select at frame 0, and we'll skip through to the end. I've got 300 frames in there. make this 100%, and we record that. Let's see what happens now if we just run the sequence. So we switch to camera 1, and we're not switching to anything else. So we still got a bit of an issue. Now what that is, if we just select our camera null and we go to our top view, we can see that it's over here and it needs to be in the center. So what we can do is just remove this, or remove these from there for a second. We're going to get an error, but that's not a problem because there's nothing in the camera null anymore. And all we need to do is zero out our coordinates. And then we can drop our cameras back into the camera null. And that corrects that problem. And now let's see where we are. So we are, yep, that's in the middle, and these are all ready to go. So let's just switch back to our 3D view, F1. And now we're ready to take another look. Let's see what happens now. So we switch to camera 1, switch to our top view, switch to camera 2. Yeah, we're switching quite quickly, but we can see that it's all working. Fabulous. So that's correct. The code is correct and it's all working. The only thing we might like to play around with are the difference vectors. So what we'll do, we could leave this one as it is, but I think we'll make this one a little bit shorter. So let's make this, say, 3000. And let's see what happens now. That's a little bit longer, isn't it, before we switch? Yeah, I mean, that kind of works. It shows us that everything is doing what it needs to do. And I mean, you can play around with this if you don't like that. Make it a little bit shorter. Make it, say, 2500. You can just play around with this to your heart's content. But that keeps things a little bit longer. But there you go. It works. It does exactly what I said it would do. So yeah, I mean, that's how you go about doing this. But make sure when you've grouped your cameras, always make sure it's probably best to bring a null into the scene so that it starts in the middle of the scene, and then select all of your cameras and group them into a camera null rather than just selecting all the cameras and then Option G. Because you get your camera null in the wrong place. If you've got the flying camera, it's different if you've just got the 4 cameras at the corners here. But if you've got a flying camera as well, you're going to cause problems. But anyway, that's how you go about creating a rig to automatically switch cameras using the stage object. Yeah, that's how you go about doing it. And that's what I wanted to show you in this tutorial. So that just about brings us to the end of this one. And as always, I really hope you've enjoyed doing this tutorial and that it's inspired you and given you some ideas for things that you may be able to incorporate within your own projects. And if you have enjoyed the video, then please give it a like. And of course, if you haven't already, please subscribe to the channel, leave a comment and ring the bell. And wherever you happen to be on social media, then please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings the curtain down on this one. So I'll see you very soon on the next tutorial.